So we were talking piecewise functions, and we just about got this wrapped up. Here's the example we left off on, right? So remember what we were doing with these things. When we see a piecewise function and we want to graph the piecewise function, we've got to, first of all, establish, where does each piece live? Where's the domain of each piece? In this case, it looks like the important numbers where we're switching pieces are at 0 and at 6. Everybody agree? Those are the places where if an ant's walking along this thing, he's going to jump from red to blue and then from blue up to green, right? And so, quick review what we did yesterday. So we want to maybe draw some vertical boundary lines. And then all we need to do if we're graphing lines, and that's really all we're going to do is just graph piecewise functions with linear functions. We've just got to graph each equation in its domain. And for lines, all we need are 2 points. So all we need to do is just create a little t-table and pick 2 convenient points to graph the line. Typically, one of those points we want to, one or both of those points we want to be the boundary points, right? And that's what we did yesterday with this second example. Okay, where we left off was we were writing down the domain and the range, right? We did the domain, but we didn't quite get to the range. So on this one, let's take care of that. Let's look at the range. All right, so what's the range? Dayton, what's going to be the range of the red piece? And the red piece, again, it's kind of messy here, but it looks like it starts right there and then just kind of goes up forever. Okay, 0 to infinity. And it would be 0 to infinity with an open endpoint at 0, right? Because the red does not include 0, right? Notice the red domain doesn't have 0, x equals 0 as a part of it, and so we end up with this open endpoint for the red piece of the piecewise function. So there's the range of the red piece. What about the blue piece, Miranda? What's going to be the what do we add from the blue piece there? What's the range of the blue piece? Between what y values? -1 and -4, good. And we got solid endpoint at -1, and it looks like open endpoint at -4. And then what does the green add to that? Anything? What's the green do? Melanie, what's the green do? What y values does the green add to our range that we're graphing here? I'll make that a little darker. So that's what we've got so far. What y values are being included on the green function? We're just trying to project all the y values onto the y-axis so we can look at each of the ranges of each of the pieces all put together for the range of the whole thing. So what's the y value where the green piece of the function starts? Looking at y coordinates. It looks like it goes up forever, but it does have a bottom y value. -1, exactly. So then this piece right here is going to go over and we're going to get an open endpoint there, but it's already filled in, right? That's a piece of the range that's already been filled in. And then from there, it's just going to go up forever. And so what do you know? It fills in that hole right there. And so what's my overall range then? If I look at the range of all those pieces combined, Johnny, what do we get? -4 infinity, good. Parenthesis or bracket with the -4? That's open. Parenthesis, okay. Okay, give me 1 to 5. Everybody get that? How we got that stuff? But 0 was filled in by the green range. So I guess I should have probably filled that in then, right? So that open one at 0 got filled in when we added the green range on top of the others. Okay, so that's just what we just did right there. We can get rid of that one. Okay, let's look at just a quick example here of whoops. Let's look at a quick example of just evaluating functions. This is really easy, right? With the graphing stuff is much tougher. So given that first piecewise function up there, let's see, you need that one right there. Yeah, that's the only one you need. So given that first piecewise function, how many pieces in the piecewise function for part one? How many pieces are in the piecewise function? 2, yeah. Okay, so we want to evaluate this piecewise function at these different values of x, the input. So what about part A, f of -5? How am I going to do that? I'm going to plug in the -5 for x. Okay, but in a piecewise function, I got to be a little bit careful with that, right? I have to determine which piece are we plugging that x value into, right? So what do you think? Give me use your thumbs. Point up or down with your thumbs. Which piece does -5 get plugged into? The top piece or the bottom piece? Oh, I'm seeing a variety of different votes here. Well, just ask yourself, look at the domains. Is -5 less than -2? Okay, so then it's the top piece, isn't it? Right? Is -5 greater than or equal to -2? No, it's not, right? So -5 is going to go into the top piece, okay? So we're going to end up with, what do we get here? So -5 is less than -2. So we're going into the blue piece on the top. So f of -5 just equals -5 squared minus 1. Plugging straight into the top one. So what's that give us? What's -5 squared? 25 minus 1? 24. Okay, what about B? -2. Now look closely at those domains. Which piece does that x value go into? Go with your thumbs, top or bottom? What do you think? Definitely the bottom. How come the bottom? Equals. There we go, right? Because of that equals right there. So that's going into the bottom piece, and we would just get f of -2 equals 5 times -2 plus 3. What's that? What's 5 times -2? -10 plus 3? -7. Okay? Give me thumbs. How we doing? Okay, getting there? All right, what about f of 7? Arson, which one's that going to go into, top or bottom? Say it again. Bottom, yeah, good, because 7 is greater than or equal to -2, isn't it, right? So this one's going to give us 5 times 7 plus 3. So what is that, 35 plus 3? What's that, everybody? 38. There we go. Okay, let's try this one more time here. How about this guy here? G of 2. Is that going, you just tell me, is that going into top, middle, or bottom? Everybody agree? Bottom? Okay, so let's color code this. So that's going into the bottom, isn't it? How about G of -1? Abby, where's that one going? If I'm inputting an x value of -1. Is -1 less than or equal to -4? No. Middle one, yeah. Yeah, because -1 is greater than -4 and less than 1, isn't it? Yeah, good. Okay, so that's going into the middle. And then how about the part C? Mackenzie, where's that one going? Middle. Is -6 greater than -4 and less than 1? Top, there you go, good, because it's less than or equal to -4, isn't it? Okay, everybody give me thumbs on that. Does that make sense? We're putting, okay, good. All right, and then last algebra example. We're just going to work backwards on one of these. How about? So I'm giving you the graph of a piecewise function, and I want you guys to write down what is the function. Let's color code this. So this is going to be, that's an open endpoint. Let's make sure that's really clear. That's an open endpoint. And then we'll make this the red piece, and that's a closed endpoint. Okay, so let's do the red piece first. How about? Okay, so I need the red piece has two parts. It's got to have the graph. You know, what is the function that we're graphing, and then the domain. Let's start with the domain. And instead of, like, a lot of times, I know on these worksheets they always say if f of x equals x squared minus 1 if x is less than or equal to -2. I'm going to write this a slightly different way. A lot of times we don't use the word if. We just put a comma there. So for the red piece, I'm going to put a comma, and then what's the domain of the red piece? What do you think? To essay, what's the domain of the red piece? X is what? Say it again. Well, I want to know what are all the x values that are contained in the red piece, right? Because think what the domain does, right? The domain, if I go back a little bit, let's go back to like this example here, right? The domain of the red piece here was x is less than 0, right? And so we ended up with, it's got kind of messed up, but we had an open endpoint on our red piece, and then it went to the left of 0, of x equals 0 forever, right? Like if we go back, I don't think I have those on. Those are, I erased all the examples. Those are on the notes from yesterday. You see what I'm saying though? What are the x values that we could input into the red piece? -infinity to, what's the biggest x value in the red piece? 0. Okay, and we're including 0, aren't we? When we write this with a piecewise function, we usually just want to write it as an inequality, though. So that's the correct, the domain is, this is correct. It's -infinity to 1 with a bracket, but I need to say that as an inequality. How would I say that as an inequality? Trenton, how would I say that as an inequality? X is what? X is less than or equal to 0. Okay, does that make sense? Everybody, so that's the domain of the red function. Okay, so now we just need to know what is the red function. Well, I mean, it's a line. It looks like it's pretty clearly a line. What's the y-intercept? 0, isn't it? Like if I look at that red line, it looks like b is equal to 0. What's the slope? It's 1, isn't it? If I pick any 2 points, look, I'm rising by 1 and running by 1, aren't I? So m is equal to 1 and b is equal to 0. So I'm just going to write mx plus b, a line in slope-intercept form, where m is 1 and b is 0. So what's that? What's our equation for the red line then? What is that equation? Y equals x plus 0, right? So just x. 1x plus 0 is just y equals x. So I'm putting an x there, right? Everybody see that? So we built the first piece, right? Here's the equation. There's the domain, okay? Give me 1 to 5. How are we doing on that? Okay, we're doing all right. Okay, that's good. How about the blue piece? What's the domain of the blue piece? Let's do that first. Domain of the blue piece. Let's see, Ben. X is greater than but we're looking at the domain, so just the x values. Does that make sense? 0, right? The domain of the blue piece, just the x values start at x equals 0 and go to infinity. So we could write it using interval notation like that, couldn't we? Right? But we want to say that as an inequality. So we're just going to say x is greater than 0. Okay? What's the equation of that line? Y equals what? Say it again. 2, yeah. So what goes there? 2. Okay? Good? All right. Last thing I want to do is I just want to show you how to do this with technology, and then I'm going to turn you loose and let you work on this stuff. So with Desmos, the way that you write a piecewise function, and you can go ahead and pop open Desmos if you'd like and just do this with me. Here, I'll tell you what, I'm going to start from scratch with this, what I'm going to do. Let me... Okay, so here's how you do this in Desmos. When you want to create a piecewise function, we're going to start with f of x, of course, right? We're going to use function notation. So f of x equals, and then it's a little bit strange. It works kind of backwards. So we're going to set up, notice we have one of these brackets, right, for piecewise functions. So we're going to open a set of brackets. So that's those guys, the squiggly script brackets. Okay, and then inside the script brackets, we're going to include all 3 pieces of our piecewise function. Now, to do that, here's the recipe for building a piecewise function in Desmos. You do the domain of each piece first. So I would do x is less than or equal to -2, and then I have to attach that to a function. The way I do that is with a colon. So I do the domain first, and then I do colon, which is just the 2 periods lined up vertically, right? I do a colon, and then I type in what the equation is. What is y equal to? So it's equal to 2x. And look what it does. In the graph, it does exactly what it's supposed to do. It graphs that line, but the line stops at x equals -2. Okay? If I want to add another piece, then I just do a comma, and I do the same thing for the next piece. So what do you think I'm going to type next for the middle piece? What do I put in first for each piece? The domain. Okay, so I need to go -2 less than x less than 4. Now what? Colon. And then what? -1 minus x. And look what it did. How about that? Okay. And then finally, what do I need to do now to get the last piece in there? If I want to include another piece, what do I have to do? Comma, right? Got to have a comma to separate each piece. Comma, domain. So x is greater than or equal to 4, colon, -3. And what do you know? I got it. Okay, pretty cool. Okay, what's the weakness of Desmos's graph here, though? What's the weakness? Ours are better in a way than Desmos. What's Desmos not showing us that ours do show us? Open and closed endpoints. Yeah, we can't see from the graph which pieces get to keep the endpoints, right? There's a really easy way to fix that though. All I've got to do is go down here, and I've already defined the function. So I'm going to put in, I'm going to input the boundary values, right? The ones at the values of X where we switch pieces. So like -2 is one of them, agreed? -2 is one of the places where we're changing from, in this case, we change top to middle, right? So I'm going to make an ordered pair where X is -2 and Y is just F of -2. I'm going to let Desmos attach that -2 using the piecewise function to the right piece, and look what it did. So now we can see that we get a closed endpoint on the right edge of that leftmost piece, okay? And then next to that, I'm just going to put a comma and add another ordered pair where I'm inputting what X value? It's the other X value I'd want to know about. Vote with your fingers. You can just show me how many, like, what's the other X value I want to input here? Yeah, good. Everybody see? Not everybody's voting. What's the other X value we need to know about? Yeah. Okay, not 2. I think, I know, you're counting by 2s maybe, right? I mean, it's 4 is the one where we're going to change from middle to bottom, right? And you can see on the graph, X equals 4 is where we make a jump. So I need to put in 4, F of 4. There we go. How about that? And I can even, if I turn the label on, it even tells me what the ordered pairs, what the ordered pairs are for the endpoints. Okay. Pretty handy. Okay. Give me 1 to 5. Does that make sense? How we did that? Okay, good. All right. So then here's I'll just leave this in the notes. So there's the recipe. I actually left you a link if you want to use this link to go to that document I just built in Desmos. You can go to that Desmos document, and there's just kind of a copy of the picture. Now the picture doesn't have, let me take those off. The picture doesn't have the open endpoints. I guess I'll leave them on, but those are implied, aren't they? Right? It graphs the closed ones. The other ones would be the open endpoint. So use your imagination on the other ones. All right. You guys, and then for those who want to have it available, I put in the instructions on how to do this on a TI 84 plus color edition and the regular other TI calculators if you want to do piecewise functions. I left some stuff in the notes here so you can see how to do that if you want.